Alright, so I'm going to look at in this video is points of intersection, mainly between a straight line and a circle, but just kind of refreshing something that we know already and kind of linking this to something we've seen in the course already. In algebra, you can get a question like this: solve for x and y. 2x plus y equals 5, x minus y equals 4. So I solved those using simultaneous equations, and this one is kind of set up nicely for me that I don't need to, if I just add these two equations together, I'm going to get y minus y is 0. That's what I'm looking to happen to eliminate one of the letters. 2x plus x is 3x. 5 plus 4 is 9. 3x is equal to 9. Well, then x is equal to 3. And then I just go back and I solve for the other letter. So if I use the second equation, x minus y equals 4. 3 minus y equals 4. Bring the 3 over. Minus y equals 4 minus 3 is 1. So if minus y is 1, then y is equal to minus 1. Okay, and if we're solving this in an algebra question or in paper 1, that will be me done. I've solved for the two letters. This can come up on paper 2 in coordinate geometry of the line as well. And what I have found here by solving this is the point of intersection between these two lines. So if you were to draw 2x plus y equals 5 on a coordinate plane, it would be a straight line. If you were to draw x minus y equals 4 on a coordinate plane, it would be a straight line. And the point where they meet or intersect is 3 minus 1. So when we solve a simultaneous equation, that's what we're doing. We're finding the point of intersection between two straight lines. And as I said, it can come up looking like this on paper 1, where it just says solve for x and y, or it could say find the point of intersection between these two straight lines. That would mean intersection, the point of intersection between the lines, if you see that symbol. Equally, I can get a question like this on paper 1. Solve for x and y. X plus 3y equals 10. X squared plus y squared equals 50. And we now know, having studied the circle, that x squared plus y squared equals 50 is a circle. X plus 3y equals 10 is a straight line. All right. So what this is actually asking me to do, solve this for x and y, is to find the point of intersection between this circle, which will look like that, and this straight line. So you're being asked to find the two points of intersection between this straight line and that circle. All right. If it comes up on paper 1, it looks like this. They tend not to mention the fact that it's a circle and a line. If it comes up on paper 2, so this is the same question asked a slightly different way. Find the points of intersection of the line x plus 3y equals 10 and the circle x squared plus y squared equals 50. Okay, so we solve these two equations for x and y. These are also simultaneous equations because they're two equations with two variables that we're trying to solve, but I use a slightly different method than over here. Okay, what sometimes people are tempted to do is go, okay, this is x squared plus y squared equals 50. This has got an x and a y in it. Why don't I square everything here and then I'll be able to solve it the same way over as I do this one. You're not able to do that. I won't go into it now, but just don't do that. Okay, the way to solve these is not just to square this one and then try to do it the same way as down here. Okay, the way we do it is we rewrite the straight line as either x equals something or y equals something. Okay, so we rearrange this so that it's x equals something or it's y equals something. The easier one to do here is to write it as x equals something, because x is already on its own. There's no coefficient in front of it. So if I just move the 3y over, this is now x is equal to 10 minus 3y. All right, so that's my first step, is to get x equals something. All right, the reason I wouldn't do the y is to get y on its own, you'd need to divide across by 3 and you'll end up dealing with fractions where you don't have to. So way easier to isolate the x, get the x on its own. Once you have got the x on its own in your line, what you are going to do is sub 10 minus 3y in for x in your circle. So instead of x squared, you're going to have 10 minus 3y squared. Then you'll just have y's here, you'll square it out, you'll get a quadratic, you'll solve for y. Okay, so again, I suppose the problem with solving these is they've got two letters in them. So by rewriting this as x is equal to 10 minus 3y and putting that in here for x, I give myself an equation with just y's in it, so I'm able to solve it. So as I said, instead of x squared, I'm now going to have 10 minus 3y squared. Still got my plus y squared equals 50. And now this is what I'm solving. All right. So first thing to be careful of here, 10 minus 3y to be squared. All right. I'll just write that up here. So 10 minus 3y squared means 10 minus 3y multiplied by 10 minus 3y. So if you're to multiply that out in full, 10 times 10 is 100. 10 times minus 3y is minus 30y. Minus 3y times 10 is minus 30y. And minus 3y multiplied by minus 3y, minus by a minus is a plus, 3 by 3 is 9, y by y is y squared. So that's what you get when you multiply all this out, okay? And then you've got minus 30y minus 30y, minus 30 minus 30 is minus 60. So what sometimes people tend to do is go 10 squared is 100, minus 3y squared is 9y squared. You've got most of it there, but you're missing that minus 60y term. All right, so don't forget when you're squaring a bracket out like that, you're multiplying the bracket by itself, so you'll end up with 4 terms and then 3 terms when you put the like terms together. All right, so this squared is equal to 100 minus 60y plus 9y squared plus the 9y squared I already had equals 50. So now I've y squared, y's and numbers, so I got everything over to one side equal to 0. So I've got 9y squared plus 9y squared, that's 10y squared. I've got minus 60y. And if I bring the 50 over the equal sign, it becomes minus 50. 100 minus 50 is 50. And that's equal to 0. So 10y squared minus 60y plus 50. I would probably just go and use minus b here to solve this. All right, so your a is 10, your b is minus 60, your c is 50. Sub that into the minus b formula. It would give you your two numbers, okay? I'll solve it by factorizing here because that'll just be a little bit quicker. But if you're not too sure about solving these by factorizing, just jump straight in, do that using minus b, get your two solutions out, all right? If I was factorizing this, I would probably divide across by 10 first. And I would get y squared minus 6y plus 5 equals 0. And then it's y minus 5, y minus 1 equals 0. So my two solutions are y is equal to 5, y is equal to 1. All right, so if you had it gone minus b with this quadratic here, they're the two answers you would have got out. Okay, y is equal to 5, y is equal to 1. Now, just as when over here, I got the x that wasn't finished, I have to sub back in and get y. When you get the y's here, you need to sub back in and get the x's, okay? So use this here to get your x's, okay? So I've already got x is equal to 10 minus 3y, so I'm just going to sub 5 in there, and I'm going to sub 1 in there, and then I have my x's, all right? So x is equal to 10 minus 3 times 5. That's 10 minus 15. 10 minus 15 then is minus 5. So when x is minus 5, y is 5. So that's the point. Minus 5, 5. All right. right? And that's one of your points of intersection. Over here then, so go back to x is equal to 10 minus 3 times 1. That's 10 minus 3, and that's 7. So when x is 7, y is 1. So that is the point 7, 1. And there your two answers. Okay, so your points of intersection between this straight line and this circle are 7, 1, and minus 5, 5. All right. And as I said, this topic can come up on paper 1 as just an algebra question looking like this. It can come up on paper 2 in the circle looking like this. So it's well worth your time getting the hang of this. Okay, it's good value for your time because it can come up on both papers. All right. I'm just going to go on then and do a second example. So just to highlight, I suppose, what we just saw there is a straight line and a circle, and there's 2 points of intersection between them. Okay, so that absolutely can come up in our course, and that's what we just had to solve. Okay, 2 points of intersection between a circle and a straight line. Obviously, you can have this situation here where you've got a circle and a straight line, and they don't intersect. Okay, if this happens, you wouldn't be able to solve the quadratic. You're not going to see this on our course. You don't need to worry about this situation where they don't intersect. What we might see sometimes is where there's 1 point of intersection. Okay, so you can have the line going through the circle and touching it twice or intersecting it twice, or you can have the line just touches the circle in 1 point, and that's called a tangent. Okay, so if you're ever asked to show a line is a tangent to a circle, one way of doing it is finding the point of intersection between them, and if you only find 1 point, if you only find one answer, you've shown that that line is a tangent to a circle. All right, so that's the situation we have over here. Okay, so the question is asked slightly differently here. Show that 3x minus y equals minus 10 is a tangent to the circle x squared plus y squared equals 10. So to show it's a tangent, I'm going to do exactly what I did here. Okay, I'm going to find the 1 point of intersection between them though. So when I go and solve this, when I get my quadratic, I'm only going to get one solution, and that shows it's a tangent. So the way I start it is exactly the same as the other one. So I take the straight line and I rewrite it as either x equals something or y equals something. Writing it as y equals something will be easier here because the y is on its own. It doesn't have a coefficient. All right. Whereas this has a 3 in front of it. So if you were to try and get x on its own here, you'll end up dealing with fractions. You'll make the question harder than it needs to be. So what I would do here is start with 3x minus y equals minus 10. I want my y positive, so I'm going to move my y to the right hand side. I want it on its own, so I'm going to move the minus 10 to the left hand side. So the 3x isn't moving. The minus 10 is moved over and becomes plus 10. The y is moved over and becomes plus y. So I've just rewritten this line as y equals 3x plus 10. And what I'm going to do now is wherever I've got a y in my circle, I'm going to sub in 3x plus 10. So I'm going to replace the y here with 3x plus 10 because I've just shown that 3x plus 10 and y are the same thing. So take your circle and rewrite it as x squared plus 3x plus 10 squared equals 10. All right, so isolate the x or y in the straight line and then sub in to the circle. The 3x plus 10 squared, so again, same thing as I had last time, just be careful when you're squaring that out. 3x plus 10 squared means 3x plus 10 by 3x plus 10. 3x by 3x is 9x squared. 3x by 10 is 30x. 10 by 3x is 30x. 10 by 10 is 100. Putting my like terms together then, I get 9x squared plus 60x plus 100. So when you square this out, this is what you get. Okay, so I have x squared plus 9x squared plus 60x squared plus 100 equals 10. So let's get everything over to one side equal to 0. So 10x squared plus 9x squared, sorry, x squared plus 9x squared is 10x squared plus 60x. Bring the 10 over, it becomes minus 10. 100 minus 10 is 90. And that's equal to 0. Okay, so again, I would say do this using the minus b formula. It should only give you one. Yeah, so look, I'll do it using the minus b this time rather than factorizing. Okay, so if I'm going to solve this using minus b, this is a. So a is 10, b is 60, and c is 90. Okay, my minus b formula is that's on the front of my log tables here. Alright, so x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. So let's sub into this thing. Minus b is going to be minus 60 plus or minus the square root of b squared is going to be 60 squared minus 4 times a is 10 times c is 90 all over 2a, so that's all over 2 times 10. So this is equal to minus 60 plus or minus the square root of, let's work this out underneath the square root. So I've got 60 squared minus 4 times 10 times 90, and that's equal to 0. Okay, and that's what I'm expecting in this question. So I get minus 60 plus or minus the square root of 0 over on the bottom 2 times 10 is 20. So minus 60 plus or minus the square root of 0. What's the square root of 0? It's 0. Okay, so if you were to try and do your two answers here, you'll get minus 60 plus 0 or else minus 60 minus 0. They're both the same. Okay, so adding or subtracting 0 doesn't make a difference. It's not going to change what you have there, minus 60. Okay, so that's what you expect when you're finding a tangent, because you're only going to get one solution here. Okay, so when you're finding a tangent, you're only going to get one solution. So expect this. So I can stop worrying about the plus or minus 0 and just go minus 60 divided by 20. So minus 60 divided by 20 is minus 3. So x is equal to minus 3. All right. Don't forget then, you're also looking for the y. So I would use this equation of the line here and just sub minus 3 in. So 3 times x, so I've just figured out x is minus 3. So 3 times minus 3 plus 10 equals y. 3 times minus 3 is minus 9. Minus 9 plus 10 is 1. So 1 is equal to y. So your answer, your point of intersection is minus 3, 1. Okay, and then maybe just write a sentence. It's a tangent because there's only one point of intersection. All right, just to make your answer really clear. So one point of intersection, therefore it's a tangent. All right, if I'd kind of done the minus b out in full for the previous example, I wouldn't have got 0 here. So I would have had to do the plus and the minus separately, and that's what would have generated my two solutions for this one. Okay, so to find the point of intersection between a line and a circle, you start with the equation of the line, you isolate either the x, like I did here, I rewrote it as x equals something, or you isolate the y, I rewrote it as y is equal to something, and then you sub the other half of that in for y in this case. I sub the other side of this in for x in this case. You end up with a quadratic. Solve that, gives you 2 x's or 2 y's, sub back in to get your y or x, the other side of your point. If you only get one point of intersection like I did here, you have proved you are dealing with a tangent. All right, and as I said, this comes up in paper 2, asked in terms of circles and lines. It comes up on paper 1 just asked like this, solve for x and y. So absolutely value for time in terms of putting time in and getting your head around this stuff.